Hello everyone! In today's presentation, we will talk about minerals and rocks. Let's get started! At the end of this presentation, each of you must demonstrate understanding about physical and chemical properties of minerals. You can identify some common rock-forming minerals. You can also describe and identify the three basic rock types. And lastly, establish relationships between rock types and their mode of origin in environments of deposition or formation. Let's go! To begin with, let's talk about minerals. A mineral is a naturally occurring substance, meaning they are not man-made or machine-generated. They are also inorganic. That means that they are not a byproduct of living things. They are solid, with an orderly crystalline structure. And lastly, a mineral has definite chemical composition. Let us also put in mind that minerals are the basic building blocks of rocks, such as salt, graphite, diamond, and gold. Minerals can be categorized based on their properties, such as, first, luster. This talks about the quality and intensity of reflected light exhibited by the mineral, such as metallic minerals, which are generally opaque and they exhibit a resplendent shine similar to a polished metal. For non-metallic substances also, they are usually glassy, they are adamantine in structure or they are diamond-like, they are resinous, silky, pearly, dull or earthy, and they are greasy, among other types. Minerals also can be described based on hardness. It is a measure of the resistance of a mineral to abrasion. Take a look at the minerals below. They have their numbers, and we will see what's the description of each mineral in our next slide. In 1800, Friedrich Mohs designed his Mohs scale of hardness. This is designed to measure the scratch resistance of various minerals from a scale of 1 to 10. This is also based on the ability of a harder material or mineral to scratch a softer one. Take a look at the chart below. Notice that the rating is arranged from number 1 to 10. 1 is described as very soft and 10 as the hardest. On the middle part, it has its description, and on the right part, it has the mineral example. Example, we have talc. It is categorized under 1. So the description of it is easily crumbles, can be scratched with a fingernail. Take a look at diamond. Diamond is categorized under 10. Its description is, it is used to cut all minerals. That's why they said that diamond is the hardest mineral above all. Another mineral properties are color and streak. Color is the unique identifying property of certain minerals, while streak, on the other hand, is the mineral's color in powdered form. It is inherent in almost every mineral and is a more diagnostic property compared to color. A lot of minerals also can exhibit the same or similar colors. However, take note that the color of a mineral can be different from its streak. Here are some examples of minerals showing their colors. Amethyst shows a purple color. Rose quartz displays a pinkish color. Citrine has orange. Smoky quartz has black. Opal has white. Emerald has green. And turquoise has blue color. Here are some examples of minerals showing their streak properties. Take a look. The first picture shows a picture of a hematite mineral. It has originally a black color. However, it has a red-brown streak on a piece of paper. The second picture also shows a cinnabar mineral. It has a black color, however, if you will see its streak property or its streak color, it's golden or brownish. The last picture is a pyrite. It has a grayish or golden color, however, if we see its streak, it has a black color. Crystal form or habit is another mineral property. This is the natural shape of the mineral before the development of any cleavage or fracture. It reflects the internal structure of atoms and ions. Take a look at the picture below. Minerals can either be prismatic, tabular, bladed, platy, reniform, cube, octahedral, and so on and so forth. Some minerals also show cleavage. A cleavage is the weak plane that develops after the crystal is formed. Minerals show cleavage because of their property to break along specific plane of weakness to form smooth and flat surfaces. Here are some examples of minerals showing cleavages. The first picture shows quartz mineral. It says cleavage in 0 directions, meaning it has flat surfaces, however, they are not in the same direction. The second picture shows muscovite mineral. It also has a cleavage in 1 direction. If you will examine the surface of it can give us a flat surface, as well as if you will crack the mineral, it can also give us a plain surface. The third picture, which is the feldspar mineral, show also a cleavage in 2 directions. If you will examine the top part of it is in a plain surface, that's 1 cleavage. The other side of it also has another flat surface showing the horizontal and vertical cleavages of feldspar. The last example is amphibole. If you will notice the structure of this mineral, the surfaces are in diagonal position. That's why they are called as cleavage in 2 directions, however, in diagonal structure or position. Some minerals may not have cleavages but exhibit broken surfaces that are irregular and non-planar. This is now called as fracture, and this is one of the properties of mineral. Take a look at the example below. The first picture of mineral here shows a conchoidal shape. It has smooth curve and bowl-shaped structure. The second picture shows a Hackley structure. It has sharp and jagged edges. The third picture of mineral here shows a rough and irregular surfaces. They are called uneven. And the last picture shows fibers or splinters, that's why they are called fibrous. Take note that cleavage and fracture are different. Cleavage, as mentioned before, are the flat surfaces that a mineral has, while fracture are the irregular and non-planar surfaces or structure a mineral has. Another mineral property is the specific gravity. This is the ratio of density of the mineral in the density of water. This parameter also indicates how many times more the mineral weighs compared to an equal amount of water. Take a look at this example. Water here has a specific gravity of 1, and silver has a specific gravity of 10. This indicates that the silver is 10 times heavier than water. For us to know the specific gravity, we must identify the density of a particular object, divided by the density of water, and we can now identify the specific gravity. Specific gravity also is important because there are minerals that have the same sizes, however, their weight may be different. So, with the use of specific gravity, it is easier for scientists and for us to identify and classify them according to their properties. There are also other properties of minerals, such as magnetism, odor, taste, tenacity, and reaction to acid. Take a look at the picture on the right part of the slide. This is a magnetite mineral, and as you can see, it shows us its magnetic property as it attracts the nails towards it. Sulfur also is a kind of mineral that has a very distinctive smell. The first picture here shows an example of halite mineral, or also known as the sodium chloride or the salt. We all know that it has a very salty taste. The second picture shows an example of a calcite mineral, and this calcite mineral fizzes with acid. So as you put acid on it, it creates a gas bubble on the surface that bursts and make a soft noise. Well, before we end, let's sum up the mineral properties we talked about today. First, we talked about luster, hardness, color and streak, crystal form or habit, cleavage, fracture, specific gravity, and lastly, the other mineral properties such as magnetism, odor, taste, tenacity, and reaction to acid. For concerns, please message your teachers. Our next topic will be mineral groups, and make sure that you stay tuned. See you!